In this video 2.5, we will be looking at literal equations and formulas. You should be able to say, I can rewrite and use literal equations and formulas. A literal equation is an equation that involves two or more variables. Formula is an equation that states a relationship among quantities. For example, a formula for perimeter of a rectangle. The perimeter is 2 times L plus 2 times W. The L is length, the W is width. Circumference of a circle, 2 pi r. Area of a rectangle, area is length times width. Area of a triangle, 1/2 times base times height. Area of a circle, radius squared, pi r squared, sorry. The distance traveled, distance equals your rate times your time. Temperature. Celsius is 5/9 times Fahrenheit minus 32. So here are just some examples of formulas that we use, and there's relationships among quantities within those formulas. Solve the equation 3x plus y equals 10 for y. So that means we want to get the y isolated in this equation. To do that, we would subtract 3x from both sides. So that's 0, so I'm left with y is the same as 10 minus 3x. So here we have our y isolated. What does y equal if x is 1? So we're going to take what y equals, 10 minus 3, and now I'm using 1 for x. So our y is 10 minus 3, so y would be 7. And how about if x is 3? We know y is the same as 10 minus 3x, so 3 times 3. So when you multiply first, 10 minus 9, so the y would be 1. What equation do you get when you solve the equation a over x minus b over x equals c for x? So what we want to do here is multiply both sides of the equation by x. So I'm going to show you here what happens if I write out a over x minus b over x is the same as c, and I take both sides of the equation and multiply both sides by x. It still is balanced because I'm doing the same to both sides. Now when I do this, what ends up happening when I distribute an x here and I multiply the c and the x here, I end up with a times x over x minus b times x over x equals c times x. Well, now we have common factors. X over x is 1. X over x is 1. So I'm left with a minus b equals cx. And so once again, we're solving for x. So we're going to get rid of the c by dividing both sides by c. So that is now getting the x isolated. So we can see here that x equals a minus b. Oh, and I'm catching myself here. All over c. Sorry about that, because we're dividing both sides by c. So it's a minus b divided by c. Now you could also write that as a over c minus b over c. That's another way to write it out. What is the length of a rectangle with the area of 98 square inches and the base is 14 inches? So we know that area of a rectangle is length times the width. And it says that the area is 98. So I'm going to replace the A with 98. And then it says that our base is 14, and we're looking for the length. So we are looking for the length. The width, or the base, is 14. So now we're going to solve for the L. We're going to divide to undo the algebra here, to undo the math. There's 1. So L is 98 divided by 14. And so when we simplify that, the length is 7 inches. Karen walks 3 miles per hour and covers 12 miles. For how long did she walk? So how long? In this problem, we're using the formula distance equals rate times time. And we have her distance per hour. So if we're looking at her distance per hour here, that is going to be her rate. This right here, 3 miles per hour, is her rate. That's how fast she's going, and this is how far she's going. So the 12 would be her D, distance. The R is 3, and the time is what we're looking for. So if we do our property of equality here, where we're dividing both sides both by 3, we end up with 4. So it'd be 4 hours for the time. Can you say, I can rewrite and use literal equations and formulas? Write a summary and reflection and be prepared with questions for the work time and class.